Hello, PLP pre-calc. Today we're going to be looking at concept 11, zeros of polynomial functions. We're going to start with some vocab and definitions and some formulas. The fundamental theorem of algebra says every nth degree polynomial function has precisely n zeros. So all this is saying is if you look at the highest degree of a polynomial, so on A, you have a first degree polynomial, x minus 2. There is exactly 1 0 for that, and that 0 is x equals 2. On B, we have an example of a second degree polynomial that has a repeated 0. This would mean that the 0 has a multiplicity of 2. So f of x is equal to x squared minus 6x plus 9. That can be factored down to x minus 3 times x minus 3. So there are exactly 2 zeros. That 0 just happens to be the same 0, but it occurs 2 times. The linear factorization theorem: if f of x is a polynomial of degree n, where n is greater than 0, then f of x has precisely n linear factors. The rational zero test: if the polynomial has integer coefficients, then every rational zero of the polynomial has the form p over q, where p and q have no common factors other than 1, and p is a factor of the constant term, and q is the factor of the leading coefficient. So I'm going to go ahead and pop down to this first example so we can talk about what that looks like. Pardon me. So p over q, your rational zero test. You are going to take your p value and your q value, which in this one, our p value, it is the factors of 6. So that's going to be positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. And our q factors here, our q value is just a 1. So it's just positive and negative 1. So again, these are our factors of 6. These are our factors of 1. And then we can create our rational zero list. This is the list of possible rational zeros. Anytime you have an a value of 1, that leading term's coefficient is 1. Nice and easy because that 1's just going to go into the denominator and we don't actually have to account for it. So we would have positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. So this is our list of possible rational zeros. So now we need to actually find those rational zeros. There's a couple of ways you can do this. You can find f of those numbers, and if that number gives you a 0 back as your remainder, then that means that it is a factor. You can also just use synthetic division. I recommend using synthetic division because we are going to then factor down all the way. So we want to get to those values anyway. So I'm going to set up my synthetic division here. So I've got coefficients of 1, negative 1, 1, negative 3, and negative 6. And then you're going to test your values. So I already know what zeros we're looking for, but say I didn't and I wanted to start with a 2. So I'm going to do my synthetic division like normal. Drop my 1, multiply, add, multiply, add, multiply, add, multiply, and that gets me to one of my zeros. So our first 0 that we would know is a 2. Okay, now from here, this is actually a kind of neat concept because we can look at our now last term, and that can help us rule out 6 is no longer a viable option. 2 is no longer a viable option. 3 is not divisible by 2 or 6, so we cannot have those zeros anymore. But we can still try our others, so I'm going to try negative 1, drop my 1, multiply, add, multiply, add, multiply, add. So we get that our second 0 is negative 1. So we're going to write our function f of x is equal to, we know, x minus 2. From this first factor of 2, we know x plus 1 from our second factor. And then we are left over with, we've got 3 terms here, so we're going to have x squared plus 0x plus 3. So just x squared plus 3. Now, we can break down that x squared plus 3 a little bit further. If we just have x squared plus 3 equals 0, we would get to x is equal to positive and negative square root of negative 3. Let's scooch this over. I did not leave myself enough room. Which would give us x is equal to positive and negative I square roots of 3. So we can actually write this out as x minus 2, x plus 1, and then x minus I square roots of 3, x plus I square roots of 3. Which actually brings me back to the conjugate pairs, the last definition that I kind of skipped over. Anytime the conjugate pairs, let f be a polynomial function that has real coefficients. If a plus bi is a 0 of the function, then the conjugate a minus bi is also a 0 of the function. So we have a, oh, I thought I had the highlighter on. We have x minus I square roots of 3, and we have x plus I square roots of 3. So that's going to give us our 2 separate sets of zeros. All right, moving on to example 2. Find the rational zeros of f of x is equal to 2x to the 4th plus 3x cubed minus 16x squared plus 15x minus 4. So again, our p is going to be the factors of our 4, and our q is going to be our factors of 2. So I'm going to go ahead and list those out. My factors of 4, positive and negative 1, positive and negative 2, and positive and negative 4. And q, we've got positive and negative 1, positive and negative 2. So my p over q list, my possible list of zeros, this is where I have to start counting in the denominator again. So I'm going to match up. I've got all of these in the numerator over 1. So I'm going to write those out first. Got plus and minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1. So these all come from the yellow highlighted. And then I'm also going to have all of those over 2. So I'm going to have plus or minus 1 over 2, plus or minus 2 over 2, and plus or minus 4 over 2. Now, of course, with math, you can reduce those down. So our actual list of zeros, we've got positive and negative 1, which is accounted for here and here. We've got plus and minus 2, which is accounted for here and here. 4 over 2 is also 2. And then we've got positive and negative 4 and positive and negative 1/2. All right, so now we're going to continue on and find those zeros using synthetic division. So I'm going to set up my synthetic division. I've got my coefficients 2, 3, negative 16, 15, and negative 4. I'm going to pick a value to start with. I'm going to start with a 1. So if I multiply, add, multiply, add, multiply, add, multiply, add one more time, we have a remainder of 0, which means that that is a good value. So I'm going to start off my list. I'm going to, oh, not enough space over here. My x's are going to equal, we've got a 1. So my first factor is x minus 1. And then I'm going to do my synthetic division again. Again, I already know what these values are. This one is going to be one where we actually have a repeat 0. So this time we couldn't rule any zeros out, but we can have the same 0 again. So I'm going to drop my 2, then I'm going to multiply, add, multiply, add, multiply to get to my remainder of 0. So we actually have another 1. So this is a repeated 0. which means it has a multiplicity of 2 for that x equals 1 factor. So I can either write it out again, x minus 1, or I could also square it. I'll write it the other way when I write my final list. Okay, so then what we have left here, we've got 2x squared plus 7x minus 4. Now we could keep trying to break this down into nice factors, but once we get to a quadratic, we can use our lovely bottoms up method, and we can take 2 times negative 4, so we need two numbers that multiply to negative 8 and add to 7. So it's going to be 8 and negative 1. Just copying that first part down, we've got x minus 1 squared. And then our two factors, we're going to have x plus 8 and x minus 1. And since our a value was not a 1 to begin with, go ahead and divide by 2 where we can. So we've got x minus 1 squared. And then 8 divides by 2 nicely, so we've got x plus 4. 1 does not divide by 2 nicely, so this is where the bottoms up comes in, 2x minus 1. So then this would be our final factored form. And if you needed your list of zeros, you would have x equals 1, and then also x equals negative 4 and 1/2. Okay. Example 3, we are going to find a fourth degree polynomial function that has a real coefficient of negative 1, and 3i as zeros with our conjugate pairs. If we know that 3i is a 0, that also means we have negative 3i as a 0. So I'm going to write this out. We know that we have zeros of negative 1, so that would be x plus 1, negative 1, which gives us x plus 1 again. And then we have x minus 3i and x plus 3i. I'm going to go ahead and FOIL all this out. FOIL, box method, whichever way you use. I'm going to multiply these two pieces together first. And then I'm going to multiply these two together. So that's going to give me x squared plus 2x plus 1. And the second part's going to give me x squared. The plus 3ix minus 3ix is going to cancel itself out. And then we're going to have minus 3 squared, which is 9i squared. And I squared is actually just negative 1, so I'm going to make that a positive and go ahead and get rid of that I squared. So it's x squared plus 9. And then one more time, FOIL this out, or box method again, whichever one you prefer. So we're going to take our first times our first. This one's not as straightforward. So that's x to the 4th plus 9x squared. And then my second term times my first term plus 2x cubed plus 18x. And then my last term plus x squared plus 9. And just combine all of those like terms. So we've got x to the 4th plus 2x cubed. I got those together. And then I've got 10x squared total plus 18x plus 9. All right, example 4, find a polynomial function with real coefficients that has negative 1, 5, and then 3 minus 2i as zeros. Again, if we know that we have 3 minus 2i as a 0, we also have 3 plus 2i as a 0. Bear with me, this one's going to get a little bit ugly for a second, but it'll work out nicely in the end. So we've got f of x is equal to, our first 0 we know is negative 1, which means we have x plus 1 as a factor. And then our second 0 is 5, which means we have x minus 5 as a factor. Our next 0 we know is 3 minus 2i. So what that's going to look like is we're going to have x minus 3 minus 2i, and then that is in parentheses. And our next factor we know is x minus 3 plus 2i. Okay, now I'm going to go ahead and distribute this negative throughout. So I'm going to do that at the same time that I'm foiling these first two terms. So I've got x squared minus 4x minus 5. And then I've got x minus 3 plus 2i and x minus 3 minus 2i. This is where your box method might come in handy if that's what you like more. I'm going to continue with FOIL just because that's what I'm more comfortable with. But it all depends on what you want to do. So I'm going to take my first times my first. That gives me x squared minus 3x minus 2xi minus 3x plus 9 plus 6i. Out of colors. And then plus 2xi, nope, minus 6i, sorry. And then minus 4i squared, which is going to become plus 4. Like I said, it's going to get ugly for just a second, but this step is going to work itself out. So we've got minus 2xi plus 2xi plus 6i minus 6i. And then I'm going to combine all of my like terms. So I've got x squared, I've got minus 3x, so that's minus 6x. And I've got plus 9, plus 9 plus 4, so that gives me plus 13. Okay, one more time, FOIL all those together. So I've got my first times my first, x to the 4th. And then I've got minus 6x cubed plus 13x squared minus 4x cubed plus 24x squared minus 52x, growing rapidly, and then minus 5x squared plus 30x, and then 5 times 13, 65, minus 65. And then one more time, combine all my like terms. So I've got 1x to the 4th. I've got minus 6x cubed minus 4x cubed, so a total of minus 10x cubed, 13x squared plus 24x squared. That's going to give me 37x squared minus 5x squared, so plus 32x squared. And my x's, minus 52x plus 30x. It's going to give me minus 22x minus 65. So again, really ugly for a second, and then it all works out nicely. Alrighty, moving on to example 5. We're going to find all zeros of f of x is equal to x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60, given that 1 plus 3i is a 0. Okay, so if we're given that 1 plus 3i is a 0, we also know that 1 minus 3i is a 0. So we're going to go ahead and find what that is. So if we know x minus 1 minus 3i is a 0 or as a factor, and x minus 1 plus 3i is a factor. I'm going to go ahead and get these all FOILed out. It's going to give me x squared minus x minus 3xi, and then minus x plus 1 plus 3i, and plus 3xi minus 3i minus 9i squared, which becomes plus 9. So our total function here is x squared. Our minus 3xi's cancel. Our plus 3i and minus 3i's cancel. So we've got x squared minus x. Oh, so sorry, minus 2x. I missed the first one. X squared minus 2x plus 10. We can use that function and use long division to find the rest of our zeros. So for a function, I'm going to kind of shrink all of this down just so I've got a little bit more room to work with. Go right up here in the corner so it's still there. Okay. If we have the function x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60, and we are dividing that by x squared minus 2x plus 10 we're going to find that leftover function. So first I'm going to take x to the fourth divided by x squared, which gives me x squared. That tells me what I need to subtract. So I need to subtract x to the fourth. I'm distributing this x squared to each of these pieces. So x squared minus 2x cubed plus 10x squared. I don't know why I said that x squared times x squared was x squared. It is x to the fourth. And then we're going to subtract. So we're left over with 0. And then we've got negative 3x cubed plus 2x cubed, which gives us negative x cubed. Then we've got 6x squared minus 10x squared, which gives us negative 4x squared. And then I'm going to drop my 2x. And I'm going to repeat. So I'm going to take my x cubed, negative x cubed divided by x squared, which gives me a negative x. And then I'm going to take that negative x and multiply it through every piece of what we were dividing by. So that's negative x cubed plus 2x squared minus 10x, which leaves me with negative 4x squared minus 2x squared give me negative 6x squared. 2x minus negative 10x is 2x plus 10x, which gives me 12x. And then we are going to drop a negative 60 and repeat one more time. So we've got negative 6x squared divided by x squared, which gives me negative 6. And then I'm going to multiply that through negative 6x squared plus 12x minus 60, which of course gives me 0. So then this function right here is what I'm working with now. So I need to find the zeros that come from x squared minus x minus 6. I can factor that one, two numbers that multiply to negative 6 and add to negative 1. It's going to be negative 3 and 2. So my x's are 3, negative 2. And then also we have x's of 1 plus and minus 3i from the given situation. All right, we're going to do that again. We've got question number 6. Find all zeros of f of x is equal to x cubed minus x squared plus 4x minus 4, given that 2i is a 0. So again, if we know that 2i is a 0, we know that negative 2i is a 0. So we've got x minus 2i and x plus 2i, which when I multiply that out, this one's a much easier function to deal with. I've got x squared. My middle term is going to cancel out because it's a difference of squares. Then I've got minus 4i squared, which of course becomes plus 4. And then we can do our long division. Should not take as long this time. So we've got x cubed minus x squared plus 4x minus 4. And we are dividing that by x squared plus 4. Now, for the purposes of this example, I am actually going to put in a little bit of a filler here. So I'm going to divide by x squared plus 0x plus 4, just so that we keep that term in place. Okay, so take your x cubed divided by your x squared. That's going to leave me with an x. Do my subtraction, or actually do the multiplication first. So we've got x cubed minus x cubed. That gives me 0. Negative x cubed, negative x squared minus 0x squared just gives me negative x squared. Plus 4x minus 4x gives me 0. 0 x's. And then I'm going to drop down my negative 4 and do the division one more time. X squared, negative x squared divided by x squared is negative 1. I'm going to take that and multiply it through. And I come out with a remainder of 0. This one, again, much easier. We are left with just x minus 1 equals 0. So our x that results from that is a 1. And then we also have our x's from the given. So x is equal to positive and negative 2i. All right. Example 7. Write the polynomial as the product of linear factors and list all the zeros of the function. So we've got x cubed minus 3x squared plus 4x minus 2. So this one, we do need to look at our P over Q list. So our Q on this one's one of the nice ones. So our only possibilities are positive and negative 1 and positive and negative 2. Now, if you do not know right off the bat what your factors are going to be, you might have a little bit of a trial and error, which is perfectly fine. I'm going to try my synthetic division. We got 1, negative 3, 4, and negative 2 as my coefficients. Let's try negative 1. We try negative 1. I added before I multiplied. Negative 1 times negative 1, or 1 times negative 1 is negative 1. Add straight down, that gives us negative 4, 4, 8. And then when we get here, that is not going to give us a 0. So that tells us that that factor is not correct. So all you got to do is erase that piece and start over. You can get rid of that negative. You know that's not the answer. I'm going to try a positive 1. So that gives me a 1, negative 2, negative 2, 2, 2, which gives me a remainder of 0. So then my function left over is x squared minus 2x plus 2. Of course, that is for our purposes of f of x. That is being multiplied by x minus 1. Now we need to find those zeros. The easy route, easy in quotations, is your factoring. If you can factor, that is normally the easier option. So we need two numbers that multiply to 2 and add to negative 2. That number does not exist. So Instead of factoring, we need to use quadratic formula. So we've got x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, so we've got 2 plus or minus the square root of 4 minus 8 all over 2. 2 plus or minus the square root of negative 4 over 2. The square root of negative 4 is 2i, so 2 plus or minus 2i over 2. And since every piece of that is divisible by a 2, we can do that and just get 1 plus or minus I. So our product of linear factors, we would have f of x is equal to x minus 1. That's the factor we found from synthetic division. And then we would have x minus 1 minus I and x minus 1 plus I. I tried to put the plus in too soon. So this is our product of linear factors. And the list of all zeros, we'd have x is equal to 1 and then 1 plus and minus I. Those are your two separate pieces. All right, last example. Example 8, write the polynomial as the product of linear factors and list all the zeros of the function. We've got x cubed minus 3x plus x plus 5. Again, our P over Q list on this one is one of the nicer ones. So we've just got positive and negative 1 and positive and negative 5. Okay. Our function or our coefficients, we've got 1, negative 3, 1, and 5. And I'm going to go ahead and try negative 1. Multiply, add, multiply, add, multiply. That one does work out nicely. So that leaves us with our factors. We've got x plus 1 and then x squared directly from the synthetic division minus 4x plus 5. First, see if you can factor. So two numbers that multiply to 5 and add to negative 4. Negative 5 and 1. That does not work. So on this one, we are going to have to use quadratic formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Or minus the square root of 16 minus 20 all over 2. So 16 minus 20, that's going to give us negative 4. And the square root of negative 4, like we saw in the last one, is 2i all over 2, which means that the zeros that come from this one, we can divide on this one, 2 plus or minus I. So then our function as linear factors, we would have x plus 1 and then x minus 2 minus I and x minus 2 plus I. So that is our product of linear factors. And our zeros, we have x is equal to negative 1 and then 2 plus or minus I. Okay. Once you've gotten to this point, I want you to go ahead and try those problems on your own. If you are here, that means you are ready to see the answers. Ooh, maybe I can get rid of this. Technical difficulties galore. All right, here are your answers. Make sure you reach out to a teacher if you have any questions. And I hope you have a great rest of your day. Make sure you go see a teacher when you are ready for your teacher talk.